So this video is going to go over the normal curve on how to solve problems for it. On Excel, we'll be using these three skills and also looking at how to make a graph of the normal curve. So the first skill that we're going to look at is norm dis. So let's look at this example. Test scores are normally distributed with a mean of 76 and a standard deviation of 10. How many students score above 96? So you should know how to do this on a calculator at this point. You would just use normal CDF. Let's do it on Excel. So it would be equals norm dot dis. You can see it right here. Okay, and once I click on this, the easiest thing to do is to actually just go right on up to, we've typed in norm dis, and so we go right up here to the equation bar and hit FX, and now it'll be much easier to just figure out what to do by filling in the blanks here. So for X, the score that we were interested in was 96. Okay, and the mean for that score is 76. The standard deviation is 10. And then we have this weird thing, cumulative. So let me tell you what that means. Cumulative is if you want to find the area all the way to the left of the curve. So I have two drawings right here. When you put in the word true, so it tells you right down here, true or false. If I type in the word true, what that means is that I'm going to be finding the area cumulative all the way to the left of the curve. If I had typed in the word false, all I would be doing is finding out for just this specific value exactly the percent of the data points that are at this one particular value. So basically just the height, the exact y value at that point. All right. We want to figure out the area under the curve. So you're going to pretty much almost always be typing in true when you're doing these kinds of problems. Okay? And I'll say okay. You can already see the answer right there. And we can see the answer is 90.997. Personally, since I'm thinking of a percentile, I always want to turn that into a percentage, so I just hit percent right there and make that 98%. All right, so that's how we find area to the left of the curve, the percentile. Now here, this problem's a little bit different. If someone was in the 90th percentile, what would their score be? So now I want to find the opposite, the inverse of that. I want to figure out the score that gives me that percentile. So for this one, it's going to be equals norm, and because I'm finding the inverse, it's actually norm inverse. You can see it right there. Again, the easiest way to fill in what you need is just to go right up here to the FX, and here it is, and now I'm going to just type in what I need. So here I don't know the score, there's no X value, but I do know the probability, which is basically the percentile, that 90th percentile. So I'm going to type in 0.9 for 90th percentile. My mean is 76, and my standard deviation is 10. Okay. And there it is. Again, I find it a little bit, make that larger so you can see it. I always just kind of round it off just so it's easier to see, 89. All right, so we now know norm dis, we know norm inverse, so here we can find our percentile, our value. Now we want to go to standardize. So this one you actually don't even need to use a special equation, you can plug it in, but here's what we want to figure out, the z-score. Now the z-score, you do have an equation for finding the z-score. The equation for finding the z-score is simply the value minus the mean divided by the standard deviation. This you can totally plug into Excel. Sometimes you can even do it in your head, but there is another option. If you don't feel like programming in that equation, you can simply type in equals standardized. You can see it popping right on up. Again, easiest to just go right to f of x. And to plug it in, we're just going to type in our value. This is what is a z-value for someone with a score of 58. So I go to 58. My mean, again, was 76. We knew that here. Our standard deviation is 10. And okay, and there's our z-value. And that does look right. I'm just going to make that larger so we can see it. For 58 is smaller than 76, so that would be negative, and that answer makes sense. All right, so hopefully these three functions make sense to you. Now the last thing I want you to be able to do is to actually make a graph of a normal curve. So to do that, I want to figure out a graph of this exact normal curve here, mean of 76, standard deviation of 10. So what I'm going to do is put a bunch of values in here. You can see them here. I've kind of thought about this 76 to 10. I sort of said, well, I'll start at 10 and I'll keep going up all the way to about 150. So I've kind of counting by 10s, gone an average below and an average above that. So anyway, I have a bunch of values here. Now what I need to figure out is what would the y value be for that exactly. on the normal curve. So what I'm basically going to do is for each of these possible values, I'm going to figure out exactly what the y value is. What I mean by that is on the normal curve, you have all these values on the x-axis. What I need to figure out is the exact height on the y-axis, so how high each of these would be at each point. So I'm going to fill that out. I can find the height of every value on the normal curve by using norm dis, and rather than true, I just use false. So once I have norm dis typed in, I'm going to go to fx again. I'm going to type in my x value, which is 10. Actually here, so that I can autofill later, I'm going to actually just click into that cell right here. That way, later on, I'll just be able to autofill the cell. It will know to go to that cell. The mean we know was 76. Our standard deviation was 10. Now here's the only thing I do different. I want to know the exact y value on that normal curve, so I'm going to actually type in the false. It's not a percentile that I want the y value. So I'll type in the word false and say OK. And once I've done that, I can just double click right here, and that will fill in the values for all of these. You might wonder what these crazy e to the negative things are. What that is scientific notation, and what that really means is that if this was written out, there would be about 11 points before the decimal, and then you would get to the 1, 3, 8. You don't need to worry about the scientific notation because all you're going to do is ask Excel to graph this, and they will do the work for you. So now that we have all of these points, we are just going to highlight all of the data. Okay, you're going to go right up to Insert, and you're going to go over to scatter plot. You want a scatter plot because you have both an x and a y. You've got 2 points you want to show. So we need a scatter plot. We want to make a nice smooth normal curve. So I'm going to click on here, the smooth curve. And what do you know? I now have a beautiful little normal curve. If you want to move that to your own worksheet, you just go over here to Move Chart. We'll click it. We'll call it normal curve. Hit OK. And it's now on its own chart, and I can go ahead and edit it. I hope this is enough information for you to be ready for the lab. You're now going to do questions on worksheet 1, questions on worksheet 2. Then you're going to try to make a normal curve based on rolling 2 dice. All the directions are right here. And if you finish that, you can move on to the challenge, which is a counting challenge. Enjoy the lab.